Welcome to our channel. Today we will see about standardized anomaly of JJ's measures of soil moisture and bilinear interpolation of soil moisture data and nearest neighbor remapping interpolation method. So first, when you can see that to standardize the anomaly of the soil moisture, we can standardize this soil moisture data as it is, or we can select months that we want first. So after selecting the months, we can calculate the standardized of anomaly of the data. So to do this, first we should have to select a monthly the months that we want. For example, if we need to calculate the standardized anomaly of the JJ's months, we can first select the months of data from the given data source. So we can copy this code and we can paste on our Ubuntu terminal. So before doing this, you should have to check the availability of data in your directory. As we have seen, just in our directory, we can have the soil moon.nc data here in CDO directory. Therefore, since we have this data, we can simply write a code of CDO to select the months. So now enter. It is still working. Now it completes the process. Therefore, we had got this data now. That means the 6th, 7th, and 8th, 9th months. Therefore, it is the June to September data, as we have seen. Therefore, here, when you can see the first data, the first soil moisture monthly mean data, when you can see as an info, we will see that CDO info and maybe if we can write here this, we will see the data is almost the data contains full year time series data starting from 1948 to that of 2024 10th months, as we have seen here, and the initial data just you can see here 1948 the first month. However, just it has 12 months. Each years have 12 months, as we have seen, 12 months. So when you can see the selected moon data, when you can see here, only we can see here the 4 months data. So that means starting from 6, 7, 8, and also the 9th month. So here, which indicates for us the selected monthly data, especially the 4 months, as we have seen here. So the next step is what we should have to do. Now we are going to calculate the mean value. So since we are going to calculate the standardized anomaly data of the soil moisture, we should have to calculate again the timing of the data. So now we can calculate this timing. Paste here. is calculating the time mean. Already it is finished. Then after we calculated the time mean, what we should do, we should have to work on the time STD, the time STD. Based on that, we should have to standardize time. Standardization is important of the given data. So to do that, we should have to copy this term. We should have to copy this term, and here we can paste it. Now we calculated the standard time. To here we had got the standard time. Now after this, we are going to calculate again the anomaly part. The anomaly part based on just when you can see that there is just we can see the soil moisture first, which is the selected months, and then we have for the selected this months we have a time. Of selected months. This. So now we should have to take the difference 2. The difference of 2, just we can use sub, which indicates for us subtraction. So we are going to subtract the selected months from the selected months, the time mean value to get the anomaly. Therefore, to understand further about this arithmetic means like subtraction, division, addition, multiplication, and so on, just you should have to refer further on CDO manual. So you will get a number of information on CDO manuals. Copy. Here we are going to paste. And still. Now it is calculating. So it's finished. The calculations anomaly data. We had got such anomaly type of data. Just to see this information, we can see that you can see down info n ana. We can see that the anomaly parts. So the next step is calculating the standardized anomaly. To calculate the standardized anomaly, first we should have to see the anomaly based on anomaly part, and also it is based in addition to that the time standard value. So the division, the anomaly part to the time standard value would give for us the standardized anomaly data. So CDO div indicates for us the division, which represents for a division part. So for sub and also div, you should have to see that detailed information from CDO manual, and in addition to that, you should have to explore further information. Especially, there is a difference between calculating the constant terms also. Just you can add, for example, if you want to multiply constant term, just mul indicates for us for multiplication. However, if you want to multiply constant term, you should have to add C on mul term. So copy this term. Copy. And we can paste our term on our terminal. Enter. It's calculating already now. So we finished the results. So this is the standardized anomaly of our data of soil moisture, which is the selected months for JJS. Therefore, here we can see CDO info and info n in the we will see the standardized anomaly looks like this, starting from here, as we have seen from 1940 to 06. Starting from here, just we can see that the minimum mean value and the maximum values of the standardized data. And in addition to this, we can see this data goes until just the last months of 2024. Here we can see that the last month is 2024. That means 2024-09. We can, it goes just the anomaly is calculated. The standardized anomaly is calculated based on the above procedure, Or if you have a code, just you can run at the same time. Maybe we can create another terminal and we can run all this code at once within one click to get the standardized anomaly also is possible to do on our terminal. The other is what you can see, the bilinear interpolation method. This bilinear interpolation method and nearest neighbor remapping interpolation methods are very important, especially to extract for specific locations. That mean based on longitude and latitude. Therefore, here we want to extract the selected months of the JJS data using the bilinear interpolation method. To do that, just the remapbil plays a prominent role here. Remapbil, but for nearest neighbor remapping interpolation method, remapnn indicates for us the nearest neighbor remapping interpolation method. So these two matrices are very important in interpolation methods. Therefore, let's try to see the first CDO bilinear interpolation method. So copy this. For example, we can have here a lone 38.8 and latitude 8.98 for the selected months of soil moisture data. So we can copy this term. We can copy and next we can paste on our terminal and enter. It's working. Now it is already completed. So here we can see the bilinear interpolation. Already the data is extracted. The data is extracted for specific location, for this area based on latitude and longitude, as we have seen here. So now, for example, CDO, if you want to know about information, let's write this term. So we can see these values. We can see these values for a specific point extraction, for a specific location data extraction. On the other hand, we will see that the nearest neighbor remapping interpolation methods. Therefore, we have taken here similar longitude and latitude values. So now again, using this term, using CDO remapnn based on lone and latitude, we extracted we can extract the soil moisture as possible. Putting here this value also, we can put as the last as possible, or we can extract based on this. It's okay, no problem. So we can type here soil mean 6.7. Now it is extracted already now. So here again, we can see that similar results also. The extraction is similar. Now, next to this, we can see that how we can see the grid data, or how we can convert the specific location data into CSV formats or text format. So to do that, we have the following codes. We can have the CDO, the following codes. So following this code, just we can extract a specific location. We can extract the specific location. So CDO out tab, it contains the output table, date, longitude, latitude, the values of the parameter, and the interpolation method is, which is the nearest neighbor interpolation method. You can use another one as possible. You can apply our latitude and longitude as you have seen, which is previously we used. So simply based on this, these are also which indicates for us rows, the rows that we want to, how many rows that we want to write. Here, just as we have seen, almost we have some rows, and we can add some rows if necessary. If our data number is many, we can add also the row numbers, but it's possible having this for this activity. So we can copy this term. Now we should have to check first either soil CSV, whether we have or not. Just we should have to check first. So here, our data here is our directories. As we have seen, this is our directory. Therefore, we don't have soil CSV data here. So we are going to put our data here. So we should have to run the code. Now you can see here the soil CSV data is available here, as you have seen. And on the other hand, you can check it again just in another way. You can convert the nested data into text format also. It's possible. Therefore, we can copy, and also it already done. As we have seen again here, the soil as a text part, and also this one is the CSV. So when we can open this, we will see such type of results. As we have seen previously, it has date, longitude values, latitude, and in addition to that, it has a value. So the interpolation method is, which is nearest neighbor interpolation method. So we will have such type of data for a specific location. When you can see that, you can see here the longitude and latitude values just across each time series. You will find such similar results up to the results of the time series as we have seen here. So if you have any question or suggestion, you're welcome. Thank you.